Assalamu alaikum. Today, inshallah, we will know how to use the value of E standard to predict if a reaction will occur or not. Which means, if we will add many reactants together, how we will know which reactant will react with which, and if they will react even or not. If we have reactants together added, what we will do to know if a reaction will happen or not, first of all, we will choose the more negative value for E standard or the less positive, okay? The reactant with the more negative or less positive value for E standard, it will act as a reducing agent, which means it tends to lose electrons or to be oxidized by itself, okay? Okay, and of course, the opposite will be the reactant with the less negative or more positive E standard. It tends to act as oxidizing agent, or it will gain electrons from the other substance and it will get reduced by itself. Okay, let's have an example here and we will see what we will do. If we have zinc metal and zinc ions, if we will add zinc metal and zinc ions with copper metal and copper ions, what we will expect here? Can zinc react with copper ions to give copper metal and zinc ions? Or zinc ions will react with copper to produce zinc metal and copper ions? Which will be a feasible reaction, or the reaction that can happen, or which one will never happen here? How we will know? We will apply the same as we said in our last video. And as we said here, we will choose the reactant with the more negative or less positive E standard. Which one here? In these two systems, E standard for zinc metal zinc ions equals minus 0.76 volt, and E standard for the copper system equals plus 0.34. Which one is more negative or less positive? Yes, it's for zinc. The more negative E standard value, it means that this system, it tends to act as a reducing agent, or it tends to lose electrons, which means that this system, it tends to go to the left, to lose electrons. Good. When it will lose electrons, what will happen? Once again, as we said before, these electrons will be gained, of course, by the other system. So these electrons will be gained by the copper system or copper ions to produce the copper metal, which means that this substance, which is copper ions, it tends to be reduced or gain electrons, and the equilibrium of the copper system will be shifted towards right. Okay, look at the arrows you did here. This can tell you which reaction is happening and which is not. If you will use the arrow, the start of the arrow is your reactant, and the end or the head of the arrow is your product. So if we will add these four substances together, zinc and copper metals and zinc copper ions, what will happen? Zinc as a metal will react with copper as a metal, as ions, to produce what are our products? The head, zinc ions, and the head, copper metal. Okay? What about the opposite reaction? It will never happen. The opposite reaction, it will never happen. So this can tell us that if we will add these four substances together, we can never have a reaction of copper as a metal with zinc ions to give any products. The only reaction that is feasible reaction is zinc as a metal can react with copper ions to produce copper as a metal and zinc ions. And we said that this reaction is a feasible reaction. Okay, let's make it in an easy way. How can we do it in 3 steps? If he will ask you about which reaction will happen or which reaction is feasible. First of all, or the first step, you will choose the E standard value, which is more negative or less positive. Here it is this one. Then start to draw anti-clockwise arrows. So put your E standard value, which is more negative, at the top, the first line. The other system, the second line. Start to make anti-clockwise arrows and follow it to give your final reaction. The start of the arrow is your reactant. The head is your product, as we said before. Okay? If we will apply the same procedure here to this oxidizing and reducing agents. Group of halogens, as we know, we have chlorine at the top of the group, bromine, and then iodine. We know, of course, that chlorine is the most powerful oxidizing agent in halogens, then bromine, then iodine. How can we tell the truth about this? Using E standard. If we saw the E standard for the chlorine system, it's plus 1.37 volt. For the bromine system, E standard equal plus 1.07, and for iodine it's plus 0.54 volt. Once again, if we will apply or we will use the rule of value of E standard, the one with the more negative value, it will act as reducing agent. And the one with the more positive value, it will act as oxidizing agents. If we will compare here in the group of halogens, which one is more positive? Chlorine. So chlorine will always act as oxidizing agent when it is placed with any other one. Okay, so this can tell us that the more positive value of chlorine system can oxidize bromide and can oxidize iodide. Once again, this is the if we will use these two half cells or these two systems, chlorine and bromine, let's apply our rule as we said before. Which one is the less positive or more negative? Here 1.07. This is less positive. So this in this system it tends to lose electrons. If we will put it up here, bromide, and here bromine, we will put it up, then we will draw our anti-clockwise arrows. What reaction will happen here? At the start of the arrow is your reactant. So bromide and chlorine will react to produce bromine as a product at the head of the arrow and chloride ions. And so on, we can apply the same rule to any E standard values to know which can oxidize which. As a rule, if you need to oxidize any substance, you should look at the E standard value of its system and choose a system with a higher positive or a more positive E standard. If we need to oxidize iodide, so we will use a system which has E standard more positive value than 0.54. We can use the bromine system and we can use the chlorine. The opposite is not true, is not visible.